Hello, welcome to Code with Richard, and in this episode, I'm going to solve LeetCode problem number 21, merge two sorted lists. So let's get started. So up here, I copied and pasted the problem description, merge two sorted linked lists and return it as a sorted list. The list should be made by splicing together the nodes of the first two lists. Let's see. So basically that just means I can't just copy the contents of the list into a separate list. There's some memory limitations here. And so here's one of the examples that they give, some input L1, input L2, and then what the output would be. So it's pretty straightforward. These are sorted from lowest to highest, and then the output is sorted lowest to highest as well. There's also some other base cases that it gave us with empty lists for L1, empty lists for L2, or both of them being empty. And it also gives us a definition for a list node. So this one's pretty standard for a lot of the problems on LeetCode that involve linked lists. Each list node contains a value and an X, and that's pretty much all it has. And then it gives us what the solution should look like. Now it's a little bit big, so let me reduce it a little bit. Merge two lists, takes in an L1 and L2, and outputs a list node. So let's gonna put some comments here and gonna talk through my strategy for solving this problem. So my initial thought was to make this a recursive function or just some kind of looping function. And in each iteration, look at the first node. I guess we can only look at the first node because it's a single linked list. Look at the value of L1 and L2 of the head and determine which one's lower, and whichever one's lower, move it to the output. So let's write down some notes. So I'm going to loop, and in each iteration, what do I want to do? So I want to identify lowest node. So this will be like L1.val or my L2.val. And of course, we're going to have base cases as well. And so I'm going to have base cases because if L1 is empty or null, then I can just take L2 and plot that to the end of whatever output list that I'm creating. Likewise, if L2 is null as well. Or if both are empty, then there's nothing else that we can do at this point. So let's see. So we identify the lowest node. So it's L1, which is the val, or L2.val. We'll do a comparison. Let's say they both exist. And we want to append the lowest node to output. And I'm just going to say I'm going to pop. So it's not really a pop. I'm going to pop lowest node off of its list. So I could also here, I can say this is also like I can increment my pointer. This will be L1 or L2, whichever one is the lowest. And I think if we do this, then if we go back up to this example right here, I mean, in this case, when we hit 1 and 1, neither are the lowest because they're the same value, so it doesn't really matter. We'll just take 1. Let's say we take this first one, and then we have 2 compared to 1. We'll take the next one, and then we compare 2 to 3. We'll take the 2. We'll compare 4 to 3. We'll take the 3, and then we have 2 4s. And then eventually we'll get the output right here. So after I looked at this for a little bit, I decided not to do a recursive and decided just to do a simple loop. So I'm going to do a loop while I either have an L1 or my L2. Because once both are none, then I can just stop. And I want to find my lowest node. And the way that I did this is I created a helper function to get my lowest node because I thought it would be a little bit easier to do that. So let's go down here, and I just said, here's my function, get lowest node, and I'll take an L1, which is a list node. It takes an L2, which is also a list node. And then this is going to return a list node as well. One of the things that I wanted this to also do is pop this node off of these lists, or just increment my pointers. Because if this function can identify which one is lower, L1 or L2, and doesn't actually modify L1 or L2, then it's actually not doing very much. All it's doing is comparing basically the head of L1 and L2 and the values of each of these. So let's start off with some of the implementation of what this will actually do. Let's see. So the first thing is the base case. So let's say both are null. So if not L1 and not L2, then it's going to return none. Because if they're both none, then there's nothing we can do. Let's see. So else if we only don't have L1, then I know that my lower equals my L2, and then I can do a little optimization here and say, well, I know that L1 doesn't exist. I only have L2. Then I'm just going to say my L2 is none. And actually, the optimization's on this line as well. I went a little bit too fast. Basically, what this means is my lower node, this is a list node, it points to L2, but it's not going to be just a single node. It could be, but if L2 is a very, very long list, I'm just going to say lower is the head of that list and return that entire list. Because once L1 is none, I know that I'm going to take every node of L2 and just put it to my output. So this is just one of the small optimizations that I made here. And I can do the same thing if L2 is empty. I say my lower is my L1, and then my L1 equals none. So these are, again, just optimizations. You don't have to do it for correctness, although LeetCode might be looking for this in the solution for an optimization. I'm actually not sure. I didn't test it. And let's go to a more typical use case, which is, let's say L1 and L2 exist. So I can just do a comparison. So if my L1 is lower than my L2, then I know my lower is my L1, and then I can just increment my L1. L1 is L1.next, and then my last case is if my L2 is lower. So my lower is L2, and I increment my L2 is L2.next. And one of the things that I decided to do here was to, remember I mentioned this before, is I wanted to pop this lowest node off the list. And basically that just means I'm incrementing my pointer, which, oops, down. So I did increment my pointer here, and I incremented my pointer here. And so I'm actually going to return my lower, also my new L1 and my new L2. Okay, so now we can go back up to this merge to list function and check out my lowest node. So it's actually, I just call it my next node, and then I'm also going to grab an L1 and L2, and let's call my get lowest node with my L1 and my L2 here. Okay, so now what we want to do is we want to append next node to output list. So let's create an output list, and I'm going to use, I'm just going to call it my head, because it's my head of my output. Will first equal none, but I actually have to create a second pointer as well, and I'm going to call this my tail. And the reason why I need my second pointer is head is going to point to the head of my output, which I'm going to return, but I need a way to append nodes to this list. And so I'm going to keep a pointer to the tail, and I'm going to use that to append. So when I go to my append, I'm sorry, let's go down to where I'm going to append, and in here I'm just going to check to see if this is my first time around. So if I don't have a head, so if not head, which means it's none, then I can say my head equals my next node. And also my tail is also none. So I'm going to say this is my next node as well. And my else case is I actually already have a head. So remember, head just points to the beginning of the list, but I use tail to do all my appending. So tail already points to a node. So I want to point to this next node. So tail.next equals my next node. And then I need to set my tail to my next node. Again, so let's take a look at what happened here. Is we're just going to loop through while there are list nodes in L1 or L2. I'm going to grab my lowest node. I'm going to call it my next node because I'm going to append this next node to my output list. And then I have a new L1 and L2. Because remember, get lowest node actually can increment the pointers at L1 or L2. So I have to return those pointers here. If not head. So this is, I'll just put in, this is my first node. Remember, so head and tail start off as none, and this is my first node. This is just going to be whatever the lowest node is. This is going to be my next node. And then these down here are going to be my subsequent nodes. So my tail is already pointing to a list node. The next pointer is just going to point to my next node, and then I'm going to say, hey, my tail is now going to be my next node. So when I come around the next time, then I can append onto the back of that. Okay, so now I think I am done with the implementation. Let's go ahead and open up a test. So I actually created a test already. So let's see, I'm in code. This is my merge to sorted list test. We'll open this up over here. And one of the other things I need to do as well is I created some methods for my list node class. If you see some of my other videos, I like to create these methods or use these methods because they're a little bit easier in tests. So in tests, I can just create my test cases using like a list of numbers instead of actually creating a list. So I created a toList method on my list node, which you give it the head of a list and it'll just return you a list of numbers. And I'm just assuming that all my lists can only contain my numbers. I also created a string method, useful for debugging as well. So let's see. So we can go back to my merge to sorted list tests. These are my test cases here. So my two inputs, L1 and L2, if they're both empty, then of course my output's going to be empty. And then a couple test cases where L1 has one or multiple nodes, and also the flip side where L2 has one or multiple nodes, but the other list is empty. This list is just the input, the test case that LeetCode gave out, and then I created a slightly longer one as well. We can create some additional ones, but these are the ones that I decided to start out with. And then all this does is I create my L1 and L2 as actually a list. I merge them together, and then I do a comparison. And so I can, let's open up my console. Let's go to my code and let's call this, I think it's merge to sorted list underscore test and see if this works. And no, it looks like we do have an error. So let me go ahead and pause this real quick and I'll be right back. All right, so actually I took a few minutes to take a look at the error message in my code, and I actually found the issue, and basically in the rush of finishing up, I forgot to actually put a return value here. So in my merge to list, we of course have to return the head or we're not going to get anything. So thank you for your patience on that. Python is a language that I'm just learning, so sometimes I do forget to put that in there. And now we can run our unit tests, and you can see that everything now passed. So thank you very much for joining me in this episode of Code with Richard. I hope you learned something and it was interesting. If you have any questions, please leave them in the comments on the video. If you don't have any questions, looking forward for the next episode, and see you then. Thanks.